So for chapter 4, we'll be considering results and discussion. And so when we talk about results and discussion, what comes to mind? So I want to hear from you. What comes to mind? What are your views about results and discussion?
Okay, for results, that means it's a procedure of what you've done in chapter 3. If there is a test or data and data information you've gotten, maybe you there's a model that a model that you used, then you want to see the behavior of that data, you want to see the behavior of that work that you've done in your chapter 3, and if you got a result, then you could now go ahead and discuss what precept and process that was used to achieve that result.
Brilliant. Thank you. So any other view? Any other view from us?
Okay, results is actually comes up after you've stated in your chapter 3 your methodology. So it's like the graphical representation, or you're stating the simulations you use or the software that you're going to implement in what we are working on, and you're having a discussion to discuss everything, your step by step, everything you got in achieving um your what you stated in your chapter 3.
Awesome. That's great. Okay, so you've said it all. So all we need to talk about is how do we structure all of these results and graphical presentations. So when we talk about results, and discussion, so we literally really want to present results we obtained. We present results obtained from the design, from simulations, and also from experiments. So we talked about the 3 different types of research based on what we do in our last meeting. Yeah, how to draft the methodology. So now that you have completed the research, you now have results, meaning you can now evaluate the performance of whatsoever you may have done. Now you want to present the results obtained from the design, from the simulation if it's computational research, or from the experiment. So here we want to discuss the implications of the findings. Okay, so we want to take note of that, implications of the findings. And you don't just want to discuss the implication of these findings, you want to benchmark them with some existing results, okay? So you want to benchmark with what we have in the literature. You want to also benchmark with some theoretical expectations. You also want to benchmark with some practical applications. So now it means that for you to have a particular project concern, then that concern must address a problem that will be relevant not just to the academic community, but to the industry. Because you will have to validate against these three groups. Okay? What we get from research, what we get from standards, and then what we get from the industry. Okay? Now, how do we begin? So let us look at the possible subsessions. Well, you want to begin with a brief introduction. It's one good way to open the chapter. And here, you want to emphasize your objectives and the methodologies or methodology used. Because this is the time we now measure the performance, or better still, quote and unquote, the success of your research engagement. So it means that the objectives must have been addressed by the methodology. So you want to begin with that. You want to reemphasize what the objectives are and the key methodologies. Now, I'd rather turn this to methodologies rather than methodology. Meaning each objective must have been taken care of by a specific methodology. And afterwards, we want to provide an overview of the chapter. We want to tell us what this chapter is all about. You'll be considering results and you'll be discussing them. And at the same time, you'll be validating these results. So you want to explain how the results contribute to answering your research questions, okay? Because you also have research questions, okay? So you want to mention boom. So these three things. Now you realize that, well, you once mentioned your research questions in chapter 1. You provided a brief summary of the methodologies, and then you documented your objectives. Now, this is the time to put all on the scale, to weigh them to see if these have been satisfied. And afterwards, you want to begin with the presentation of the results. So here, you want to organize the results into tables using graphs and also using figures. So the results should therefore be categorized based on specific metrics. So it means that while you were conducting your research, you had performance metrics. And this will be specific or particular to your research domain. So it means that the performance metrics I may be considering when I'm performing or when I'm conducting my research in propagation, radio wave propagation will be different or may be different from the metrics I'll be considering if, for instance, I'm considering the development of some microelectronic devices. Okay, so here you want to now, in a way, okay, categorize your results based on those metrics. Then you could also categorize your results based on key findings, or better still, based on the experimental conditions. Now, this categorization will determine the subsessions that will follow. Does this make sense, please? I don't know if this
Yes,
is
sir.
okay.
So, but before we go forward, that means the categories now should be like, um, are we going to use are we using the three, or possibly, depending on your research work, one?
Yeah. Now, depending on your research work, like I mentioned, that will decide this point, these metrics. Okay. Now, it depends. If you conducted experiment, what if you ran simulation? So this may not apply, but this will apply because you'll definitely have some key findings. Okay. Probably in your simulation, you tried to develop an adaptive system. And that adaptive system, for instance, takes care of the transmission power, takes care of the bit error rate, takes care of the latency in the system, then takes care of the signal to noise ratio. Then now, depending on what, now probably takes care of the channel capacity or bandwidth. Now it takes care of a couple of metrics. Let's say the spectrum efficiency is also there. Let's say the throughput of the system is also there. Probably interference is there. Now, these are all metrics that, should you decide to measure these metrics, that will lead to some form of categorization, because I want to see what the throughput is saying if I vary some parameters in that adaptive system. I want to see how the bandwidth is affected if I introduce some other parameters in the channel. I want to see how the users contend for the scarce resources, the spectrum. Okay, so that will lead to another group of results. Okay, now I want to see how the bit error rate performance is varying with respect to changing values of the signal to noise ratio. Okay, that will lead to another group of results. So it depends. So, so that's why I said, depending on the metrics. So you need to have good understanding of what your research engagement should be. And when you know that, you must know the metrics used to measure the performance in that domain. So that will be your target, because those are the things you have to consider when you are trying to develop your algorithm. Does that make any sense?
Yes.
Mm-hmm. So, okay. So can we move on?
Yes, sir.
Yes, sir.
So now, so the next thing we want to look up now, in pulling off this categorization, what should we look out for? The type of data, right? So we are still in the categorization thing. So let's assume we are dealing with quantitative data. That's quantitative data. So let's assume this is what we are dealing with. Okay, so you want to do one thing. You want to display your measured data. An experiment, for instance. Okay? Or probably from your simulation. Or better still, the system test, if you have a prototype. And when you do this, that will still not make sense to us until you are able to provide an interpretation to that. And one way you could do that is to now use statistical summaries. We have mean, we have a variance, we have a standard deviation, we have error margin, and so on, okay? So once you pull the data, this time probably is some graphical representation, probably is some tables or whatsoever. You now want to tell us you want to provide the statistical interpretation or summary of the data. Then we are able to relate with those statistical parameters by relating with the significance of such. Okay, so let's say, for instance, I'm conducting my research in spectrum allocation. Okay, so I know that if, for instance, I want all the users to have equitable access to the spectrum, okay, in terms of contending for spectrum access. So I know that the variance must be as low as possible. The closer to zero, the better. Because high variance means there won't be equitable share of the spectrum. Okay? So it means that if, for instance, that is my research domain, spectrum allocation, and then I've developed an adaptive algorithm for spectrum access, not sensing this time, we just want to focus on, then it means that I have to ensure that the variance is low. What if the variance is high? So we know something is wrong with our model. So, but it's not a problem if something is wrong with the model. So want to check, did we make any assumptions that may not be consistent with standard practice? So this still boils down to having a good understanding of the technical dealings in that domain. You don't just want to have head knowledge. You want to understand how it applies in terms of practice. Okay? So this is one way we want to handle quantitative data. Now, what if it is qualitative data? Now, we want to present the observations, right? The system behavior. And we also want to get expert opinion, right? Because we may have conducted interviews, used questionnaires, and all of that. And we can equally pull off the statistical measure. Of these data sets. Okay. And then still under this categorization, we now want to look up the graphical and tabular representation of these results. So when you have numerical values, you want to use tables. Okay. Especially when you want to compare data sets, okay? You want to compare data sets. So you want to use tables. And then when you have to deal with trends and you want to look up relationships, you want to use graph, right? When you're looking up trends and relationship, you want to use graph. And we have different types of graphs. We have line graph. We even have bar charts. We have scatter plots. We also have contour plots, right? And so on. So let's say you are comparing trend over time. So say you want to compare XYZ metric with respect to time, where you want to use your line graph, okay? So let's assume there are categories of groups, group or categories. Here you want to compare, right? Then bar chart will be fine because you can see the variation in the trends, right? Something like that. Then if you want to look up correlation, like when you do your machine learning activities and all of that, yeah, then your scatter plot will be fine, right? And then if, for instance, you have multidimensional data, then you could use your contour plots. So let's assume you have a 3D plot and all of that. So you want to show all three sides in that plot, right? Probably there's a trend that is going this way. So it's all put together. So you want to use 3D, then you want to use contour plot of heat maps and all of that. So now that you've done this for graphical representations, then you also want to include the diagrams of your prototypes, right? Okay. You have your circuit design. This one good place to include them, okay? And then you must ensure that all figures and tables are labeled appropriately. So when you have tables, the label should be above it. So this is chapter 4. So we label with table 4.1 for my first table in that chapter. So if I have another table, the label should always be above the table. Should be table 4.2, da, 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 da. Then for figures, let's assume I have a graph. So we'll label the figure below the figure 4.1. So let's assume here I have a lot of scattered whatsoever. Then this will also be figure 4.2. So let's assume I have some block diagrams to say, well, one sensor is here, another sensor is here. Well, that's going to be figure 4.3 on and on, okay? So why figures are labeled below, tables are labeled above, okay? And then another thing you now want to also include will be the performance metrics and key findings. So we already mentioned that we could have experimental research. We could also have computational research. Or could have design-based research. So now that you want to document the performance metrics and key findings, so for your experimental research, you want to present measured values of data. Okay, so here we present measured values of data. So it could be voltage, it could be temperature, it could be current, or whatsoever. Now, for computational research, you want to, in this case, provide your simulation results, okay? And this could be the accuracy of your findings. You want to tell us the computational time. We want to know how computationally expensive it may be. You also want to provide some of the numerical outputs, right? So depending on what you may have done, you must have used some of the numerical techniques to either extrapolate data or interpolate or something thereabout, because you are playing with a range of values. And then the model will have to be predictive in a way, because this is not real life, but you are literally modeling a channel to say, well, I want this model, this mathematical model, to act the way the actual physical channel will behave. So it means that you are going to be doing some kind of interpolation and extrapolation based on the data points you may have provided. So it's going to assume, not necessarily as it's going to predict some unknown values based on the values you have provided. So you want to provide those numerical outputs. And then if it's a design-based research, well, you have a prototype, then you must have tested it. So you want to show the system efficiency. So you want to provide the power data or power consumption data. So you want to be able to figure out the energy efficiency in this regard based on the consumption and the likes. So you also want to provide the error profile, or we call it error rate, and so many other activities. So the fact that you have a prototype does not mean it does not mean it's flawless, okay? So you want to provide some of those data, whether they deviate or not, is immaterial at the time. But you've done something, so you want to provide the data that represents the true state of your design at the time. Because what you are considering an error may become an advantage if documented correctly. Okay? You never know. And then we want to provide discussion for our findings. So this is where you provide an in-depth interpretation of the results, okay? It's not good enough to say we have 0.25 mean value. What does it mean? So you now want to benchmark data with practice, okay? So does it mean that if we have zero mean, then that the system will be so powerful to lift an ice block of, say, XYZ kg? So now you want to provide interpretation to data, okay? So you want to document the implication. Now, in relation to research objectives, theoretical framework, and also existing literature. It's a form of validation, but you are not validating yet. Okay? You are literally providing an interpretation to what you have discovered, to the data you have been able to pull. So it means even when you have prototypes, you should have data. So you have to take that to the lab. You have to measure a few things. You have to check with your oscilloscope. So you must pull data out of your design. Okay, and now you want to provide an interpretation to it and the implications of these findings in relation to the objectives you define from the beginning of the research, then the theoretical frameworks that may exist depending on your research domain, and also what you may have figured out in the literature based on your literature review. And then once this is done, you want to provide interpretation to key results. So this is where you begin to discuss patterns, relationships, or trends. And then you also want to compare different data sets, right? And you want to explain the variations that may exist. Now, you also want to relate these findings to some theoretical expectations, right? Or better still, some engineering principles. So it means data is not meaningful if you are not able to document its relevance, right? So if, for instance, you are trying to interpret a particular graph and everything was moving all nicely, and all of a sudden there was a drop, and then everything came back, and then all the way, and then there was a spike, and everything went on. Well, this part of this result and this part of this result that may have led to some form of variation or change in the trend is very important in your interpretation. And you must tell how it impacts the application or the deployment of that unit, of that model, of that device in practice. Okay, and then you also want to compare this with existing trend or data to see if their variation was as good as this, and probably theirs just went a little and then went up this way and then went on. So why? Now, does this tell that there is an improvement, or is it something we should be worried about? Now, you want to mention those things. So you don't just want to say, well, the data increased from this to this and that, and so it increased then, and so what? You have to tell us the reason, okay? So the implication of these trends, you compare them, and you know that you are not just talking data, you are not relating data with the application of this model relative to the objectives and the aim of the research. And once this is done, then we cannot go for comparison with existing literature. So while conducting your literature review, you must have conducted your research in such a way that you devoted a session to related work, okay? So this is the good time to now compare your findings with existing with findings in existing literature. So here, you want to identify whether your results align with or contradict past studies. So identify. Then you also want to cite those sources, right? Cite relevant works. And you also want to discuss the similarity with your work. And if there are similarities, then there should be some differences. This is where the contribution to knowledge comes in, right? Then you want to highlight innovations. Or say some unique contributions of the findings. Okay. So if you said you were going to fill some gap in the literature, then the results must show it. And it's in this session, you want to compare your findings with the findings of some other engagements in the research community. And then once you're done with this, you want to consider possible explanation for deviations. Now, this is one aspect a lot of researchers want to shy, away from, because you want to show what you've done is flawless, it's so good, it's novel, and all of that. But regardless, we also need to document the flaws, okay? So, and those flaws may be useful relative to another application. You never know, okay? So it may be required. So you want to discuss the factors that affected the accuracy of your experiment, okay? And this could be probably measurement error, for which calibration could handle that. It could be some influence from the environment. It could be computational constraints. So probably the specification of your system didn't match what will give you, high-speed computation, so system requirement and all of that. Then you also want to document limitations or model assumptions. Okay. So all of those limitations and model assumptions that may have influenced the findings will be documented. And then you want to provide suggestion here. So there's a need for a little recommendation for refinement, for better accuracy, okay? So suggest. So you are literally telling us to figure out a way to tune the system, okay? And once this is done, you want to document the practical implication of your results. So if truly you try to address an engineering problem, then you must have solved something that will be relevant to people in real life, okay? So here, you want to explain the real world engineering significance of your work. And after that, you want to discuss how the results will contribute to academia, to industry, and to standards, okay? Discuss. So looking at what you may have done, will it call for a review or an update or upgrade of the existing standards? We want to know, okay? And then you also want to consider the impact, you know, it will have in the society, economy, or whatsoever, okay? So you want to look at external impact. So on society, economy, and the sustainability implication. So when you've done all of this, then we now come to the interesting part. One part we always want to see in your results, validation of findings. This is where we'll be able to tell if you truly achieved the objectives or the aim of the work. So this, in essence, is to ensure credibility and reliability of the research. Okay? So you must validate your findings. And this validation must adopt multiple techniques. You don't just want to validate using one technique and say, oh, well, the research is good. Okay? So how do we do this? So one way to validate is to compare with existing theoretical models. So you want to cross-check your experiment or the computational results with analytical or empirical models. They already exist. So you've developed something, so you want to benchmark to compare. And once you do that, you have to provide error analysis. Okay? Because we want to be able to tell the confidence level of your design. So that's why you probably through root mean square error estimate or whichever you want to, okay? So, but the bottom line is you must compare with existing theoretical models, and then you want to provide the threshold, okay? How well does your model approximate the existing model, okay? Then afterwards, you now try to also validate with industry standards, okay? So you want to benchmark. So there is this development of a wireless parameter stuff for the measurement of solar irradiance and all of that I collaborated in. The idea is we had a prototype, but we had to benchmark with a prototype already used in the industry. So we used both parameters for measurement to check for possible deviation, okay? So here you want to compare key performance metrics, okay? Like accuracy. You want to check for efficiency. You also want to look up the error rates, okay? So you want to see how consistent or how accurate is your model, is your prototype, okay? You don't just want to, assume it's all good, okay? And this will definitely be in consonance with standards. Okay, so for us in engineering, we have IEEE. Okay, so we also have the FDA, the World Health Organization guidelines. In case you're developing a biomedical device or medical device, we have the ISO standards for manufacturing and material properties. So if deviations exist, then you want to explain why. Okay, so you must provide an explanation. Okay, because we want to know the implication of that deviation and if there is need for improvement for compliance. Are we good for now? Just before I mention the last thing. Are we good?
Good.
Okay. So another way we want to validate is through repeatability tests, right? So we have repeatability and reproducibility test. So you want to confirm findings by repeating experiments or simulation under the same conditions. Okay, so you want to try repeated measurement. So you did just like the parameter I mentioned, which well, the paper is out there. You could search and look through. Now we had to conduct repeated tests. So if external data sets are also available, you want to do some form of cross-validation, okay? So which we also did, so data set, the available data set for that region, we compared with what we also got to check for any possible correlation or deviation and all of that. And then you want to discuss any uncertainties, right? And statistical confidence level. Discuss any uncertainties. And so far, we've mentioned 3 possible ways of validation by comparing with theoretical models, benchmarking with industry standards, and the repeatability and reproducibility test. And one other way, which you should add, is the expert validation. And peer review. Okay. Now you've developed, let's say for instance, you pick the apnea monitor project and you developed it. We don't just want to validate with all of these. Yeah, we've compared with theoretical models, we've benchmarked with industry standards. In fact, we've tried as much as we could to measure up with the World Health Organization and the FDA guidelines. Then we've also conducted the repeatability and reproducibility test. Then we also want to meet with the users, okay? The medical personnel. Let them try this out and tell us how comfortable or confident are they using this our device. And then we get the peer review. So you want to compare findings with expert opinion, right? Now, you could have industry report also to compare with, or better still, peer review. And if possible, you want to include feedback from engineering professionals or some domain specialists, okay? So let them also try this out and then give feedback. And once this is done, we say, well, you've done proper validation of your research engagement. So the last thing you want to include is summary of findings. Now, recall that we started this chapter with the objectives, and now we are going to end it with the objectives, right? So you want to ensure that each finding match an objective. So it means if you have 3 objectives, you should have 3 findings. So this is how you provide a concise summary of the research findings. Because by documenting the findings based on each objective, you realize that you must have highlighted the major contributions and confirmed if the research objectives were met or not. I think this is all that there is for the results. So in terms of presenting your results. So any question, please? So any questions, Sarah, Umar, Ali, Richard, Oyinda Mola? I can see those online.
So I wanted to the objectives you just spoke on under the summary of findings. So if we're having 2 objectives, then we're going to have 2 findings. Now I wanted to
Exactly.
ask if is it possible if we're not able to like achieve the, let's say, the 2 objectives, just one out of the 2 that was achieved, are we still going to state it under this section?
Okay, now, if you are not able to meet the objectives, then it means the aim of the research was not met. So the only way you can meet the aim of your research is to meet the objectives. And that's why we have to carefully select the aim of your research. I don't know if you get what I mean. So if any of the objectives happen not to be met in the research, so it means that the research engagement is inconclusive. So technically, you still have to continue with your research till you are done. Does that make sense, please?
Yes.
Or do you want to reframe your question?
No, that's actually what I wanted to ask. It's clear.
Okay. So any other comment or question before we call it a day? Is Richard still with us? And Umar, Ali, are they still with us?
Yeah, I'm here, sir. I'm here, sir. It's well defined. The question I wanted to ask, authority that's actually asked. So,
Okay.
so it's well defined the way you put it to us.
Okay, that sounds good then. So I think that would be all about the results and discussion for now.